All right, the title of our notes today is going to be scale factor. Now, the good thing is there's only one vocabulary word, so these notes shouldn't take very long. And the one word is scale factor. So a scale factor describes K. How much the figure is enlarged or reduced by. Scale factor is often expressed as a ratio. And now my question to you is, what is a ratio? It's just a fraction. Or we know that it's a colon. Or the word to. So blank to blank. So let's get into some practice. So a scale factor says, hey, something started off this size and was either enlarged or reduced by a certain number. So I'm going to zoom in a little bit. So we have a triangle that is A, B, C, correct? And if I say that the length of AC is 15 inches and the length of AB is 10 inches, and then you have a larger triangle called EFG with dimensions or side measuring at 45 inches and 30 inches. And I tell you that these two are similar. So in order for there to be a scale factor involved, the two objects must be similar. They must be similar. So if I say they're similar, what is the scale factor in between? So in order to find scale factor, you must set it up new to old. Meaning, in order to find the ratio, aka the scale factor, you must set it up new to old. So which one is new and which one was old? The new one would be the second one. The old one would be the first one. So it's like the pre-image and the image. Same thing, same concept. So you have to find corresponding sides. Corresponding means matching. So 30 inches new corresponds to what side? Which is 10 inches. All I need to do is divide and I get 3. And then I do it with the other sides. Let's just confirm. So I have new to old equals 3. So my question to you is, what is the scale factor? Hopefully you said that this was a scale factor of 3. Now, did it get bigger or smaller is the next question. Hopefully you said that it got bigger because you can see that the second figure is larger. So this is called an enlargement. Okay. Let's do another one. Say we have rectangle A, B, C, D. All right, so you have side of 12 inches. I'll say this side is X, that we don't know it, and this is 13 inches. Or do we know that side? And then you have rectangle A prime, B prime, C prime. So when you see the primes, that's an indication that was an automatic transformation. So we're going to write the value for the scale factor. Let's say this one's 52 inches, and this is, actually we don't want to put the X here, let's put the X here. So we need to find the scale factor. And solve for X. All right, here we go, new to old. So this one obviously is the old one. This is the new one. I have to use corresponding sides. What sides correspond? 12, and I don't have anything on the long side, so I have nothing. If this is 12, what is this one? Hopefully you say 12. If this is X, then we don't know it, right? So corresponding, if this is 13, that's 13. If this is 52, this is 52. So 52 new corresponds to old 13. Now, this was the new one, right? I can actually use a proportion to solve. So I have 52 and 13 over 12. Where would 12 go in this one? Would it go in the new or the old? Hopefully you said old. Now let's solve for X to figure out what that is. So X equals 48. So this and this side will both be 48. So now let's find the scale factor. 52 divided by 13 equals what? And then now that we have our new, we can also say 48 corresponds to 12 equals what? Both answers you get 4, and that is your scale factor. Let me ask you this. Is this an enlargement or reduction? Did it get smaller or larger? It did get bigger, and that is all for notes.